All right, so we're going to take some data, and we're going to build a frequency distribution, and then we're going to pull some more information out of the frequency distribution. And so we're going to use those rules that we set up for the frequency distribution table of finding the class limits, but we're going to need some data to do that. And so what I want to do is I am going to use, I hope I have it right here, whoops, not that, this data here. The data of out-of-pocket prescription medicine expenses in dollars for 30 U.S. adults in a recent year, 2014 probably. So here's 30 pieces of data. But notice something about this data, right? There's a pattern in here, or there might be a pattern, right? Because what we want to do with data is we want to see patterns. We want information out of this that might tell us something. But I don't see it looking at these numbers, and I can't practice numbers well enough to look at this and go, oh, I see we have such and such. There's actually a middle to this where most of the values go, and we'll see that when we make the frequency distribution. We will use that to help us get some more information out of this, and to look for pattern. But just looking at these groupings of numbers doesn't really help us much. So we're going to use those rules. We're going to find the bin width if we're going to make 7 classes. Okay, so we're going to make 7 classes. 7 classes. So let's do that. I'm going to come back over here and we'll do our data. So we have 7 classes. And so if we go through all of those data points, how am I going to do this? Sorry. I'll come over, oops. There we go. So I want to find the smallest number and the largest number in this. So if I look at this and I go, well, that's my smallest number, until I get to 155. That was smaller than 200. So I keep going along. Do I have anything smaller than 155? And I don't. So 155 is my smaller number. Now 200 is my largest, then 239, then 254, then 384, then 405. Do I have anything larger than 405? No. Well, let me come back here, and I can write that my maximum value, my X max of my data, the largest piece of my data is 405, and my X min, my smallest piece of data, was 155. So my range, which is the max minus the min, is 405 minus 155, or 250, and my bin width, which is going to be my range divided by the number of bins. Sorry, number of classes. I'll use the language of your book. Told you I'm guilty of that every now and then. And so 250 divided by 7. And if I grab my calculator here, 250 divided by 7 is 35.714, and it continues on, but I need to round up, and so my bin width is going to be 36. And so now I have the information I need to build a table. Now I'm going to build my table here. Some things I'm going to do is I know there's going to be 7 bins. So I'm just going to number 1, 2, 3, 4, 5, 6, and 7. And the first thing I want to do is I want to find my lower class. In my lower class, I'm going to start with my minimum value. And I'm going to add 36 to it, which gives me 191. And I'm going to continue to do that. I'm going to add 36 for each one of these to give me my lower class boundary for each of my classes. So that's my lower limit. My upper limit is this number minus 1. So this number minus 1, and so on. And then to get my last one, I have to add my width. Now notice, my smallest number was 155, and my largest number was 405. So all my data will fit in here. And so what I need to do now is I need to count my pieces of data. And what we do is we come in here and we go, okay, I've got 200. So I come back over to here and I put a tick mark in 200. And I repeat that for each piece of data. So I have 200, then I have 239, which goes in here. Then I have 155, then 252, then 384, then 165. Now notice I'm going through the list of numbers in here. I can't have them kind of both up on the same screen. I have them off on the side. One of the things you'll find when you work with data is it's sometimes good to print out your data or have it open in a separate window. You'll see even when we use software, it's good to do that. 296, 405, 303, 400. Did I put 303 in? Let's see. 307, 241, 241, 256, 315, 330, 317, 352, sorry, 352, 266, 276, 345, 238, 306, 290, 271, 345, 312, 293, 195, 168, and 342. And so I've made tally marks. I've gone through each piece of data, and what I'm going to do is we'll say these are my classes. And now I'm going to talk about the frequency. And so there's 3, 2, 5, 6, 7, 4, and 3. And so now I know how much of my data falls within certain areas. And what we can do here, 3, 2, 5, 6, 7, yep, is I just want to notice, I'm going to give a new symbol here. I'm going to use a Greek sigma, which means to sum or to add. I'm going to add all of my frequencies. If I add this, I get 3 plus 2 is 5, 10, 16, 23, 27, 30. And that's the total number of pieces of data in my sample. Now notice I did say I had the sample from 30 adults when I started this, and so this is a good way of double checking. My frequencies should match, the total of my frequencies should match the total number of samples I made, because each piece of data has a home in here, and so I should get that total back. And visually, we can see, look here, this 5, 6, 7, right? That's 11, 18. More than 50% of our stuff is just within these three clumped around these three bins. And we'll find ways to turn these into pictures or graphs later, but we have a way of kind of seeing some things about our data. Well, let's make this table slightly more useful and have other ways of talking about it. Remember when I said I'm not looking back at my original data, I have three things in here, but I don't know what their values were anymore. So I can talk about each class as being its midpoint. What you can do with midpoint is it's the average of the lower and the upper. And so if I take 155 plus 190 and divide it by 2, I get 172.5. And so the midpoint, which I'll put here, is 172.5. Now because the classes are 36 in width, I can just add 36 to each of these. Get my calculator here, and so 208.5, and I'll add 36 to each one. 244.5, and let's see, 244.5 plus 36, 280 plus 5.5, sorry, 280.5 plus 36 is 316.5, 316.5 plus 36. Did I type one of these in wrong? Let's see. 316.5, nope, 352.5. And 352.5 plus 36, 388, yeah, 388.5. All right. And so I can talk about these bins either as being their lower and upper values, or I can talk about them as their midpoint. And you'll find when you read other people's data, the midpoint becomes a useful way of approximating what the data is, because I've lost what the individual values were from my data when I look at it this way. And so we will get comfortable dealing with the midpoint and the bin widths. Well, I have 30 pieces of data, but I really was pulling from a larger population of adults in the US. And so I might want to infer some things from my description. So I'm going to enhance my description by talking about the relative frequency. And that's where I take the number in the bin and I divide it by my total number, 30. And so 3 divided by 30 is 0.1. Now, you'll see me talk about this in different ways. I will sometimes say the fraction 3 over 30, which is 1/10, or it's 0.1, or I'll sometimes say 10%. They all have the same meaning, and you will find that using the fraction sometimes is easier mathematically than using the decimal. I use this number to multiply so often that it's easy for us to say 10%. We've grown up with percentages. Right? I got a 90% on a test. I missed 10% of the questions. But when we mathematically use it, we would use the 0.1. And so you'll find sometimes conversationally, I will write 0.1 and I'll say 10%. And so I'm going to write the relative frequencies for each of these. So I'm going to take 2 divided by 30, or that's 1 in 15. And 1 divided by 15 is 0.066 repeating, or we'll say 0.07, or 7%. Right, I'm going to not write down the percentage right now. I'm just going to continue to write down each thing here. And so 5 divided by 30 is 1/6, or 0.166 repeating, and we'll just say 0.17. We'll round it to 2 decimal places. That repeats. So I'm using my calculator here to get these repeating numbers. But right now I'm just keeping two decimal places. 0.1, 10%, 0.07, 7%, 0.17, 17%. So 6 divided by 30, right, my frequency, divided by n. And so that's what I'm doing with this whole column. And so 6 divided by 30 is 0.2, or 0.2, I'll say 20%. I'll keep the two decimal places, so I should probably keep the 0 here so that it translates. So 7 divided by 30, because again my f is 7 and my n is 30, is 0.23 repeating, or approximately 23%, 0.23. Get my decimal in there nice and big. 4 divided by 30 is 0.13 repeating, or about 13%. And 3, we've already done, that was the first one, 0.10 or 10%. And so I have this new thing, relative frequency. And so relative frequency, again, this will be an equation in the back of your book, is the frequency for the bin divided by the total number of things you have. Now, if you keep this in fractional form, if I had the 1/10, the 1/15, the 1/6, the 1/5, the 7/30, the 2/15, and the 1/10, and I add all those fractions back up, the sum of all the relative frequencies equals 1. Now, because I had to round here, when I add up all the decimals, I don't always get 1. But the idea is, if these are parts of the whole, when I add them all back up, I get one whole thing. And so that's what relative frequency does for us. Relative frequency is a good way that we can translate from our samples back to our populations. Because if this sample was indicative of the population, then I would expect about 20% of the population would pay in between $263 and $298. And that's how we're going to use this. Another thing we can do is we can do the cumulative frequency. And so we'll put the cumulative frequency here. And what I do is I add how much of the whole I have. So when I start, I only have 3 things. But when I get to this column, I have 2 more. So 3 plus 2 is 5. Or when I get to this row, I have 10. Sorry, I used the word column before. And 16. 23, 27, and 30. And this last one should be my whole. And what it is it's a running total of how many things I've had so far. So I can say when I get here, I've had 16 out of my 30 already. And so before this is 50% of the things. And so I have 50% of the things in this window here, and 50% of the things end up being before this. And so the cumulative frequency is a way of looking for when we reach certain amounts. And when we get to the end of our list, we should have everything accounted for. And so these are ways that we can have of looking at our data. All right, what I'm going to do here is I'm going to stop this, and then we're going to look at some graphs that we can make from these. We're not going to make the graphs fully yet. We'll just look at different types of graphs and see what we can